Welcome to video 3 for this unit on Introduction to Quadratic Functions. In this video, we're going to focus on working with quadratic expressions. A quadratic function can often be defined by many different but equivalent expressions. For example, if the revenue in dollars from selling tickets at $D can be expressed with D times the quantity 600 minus 75D, then it can also be written as 600D minus 75D squared. One is a product of D and 600 minus 75D, and the other is a difference of 600D and 75D squared, but both expressions represent the same function. Sometimes a quadratic expression is a product of two factors that are each a linear expression. For example, the quantity x plus 2 times the quantity x plus 3. We can write an equivalent expression by thinking about each factor, the quantity x plus 2 and the quantity x plus 3, as the side lengths of a rectangle. Then, decompose each side length into a variable expression and a number. Multiplying the quantity x plus 2 and the quantity x plus 3 gives the area of the rectangle. Adding the areas of the four subrectangles also gives the area of the rectangle. This means that the quantity x plus 2 times the quantity x plus 3 is equivalent to x squared plus 2x plus 3x plus 6, or x squared plus 5x plus 6. Notice that the diagram illustrates the distributive property being applied. Each term of one factor is multiplied by every term in the other factor. A quadratic expression can often be represented by many equivalent expressions. For example, the quadratic expression x squared plus 3x plus 2. This is in standard form, the sum of a multiple of x squared and a linear expression. The standard form of a quadratic expression in x is ax squared plus bx plus c, where a, b, and c are constants, and a is not 0. We refer to a as the coefficient of the squared term, x squared, b as the coefficient of the linear term, x, and c as the constant term. An equivalent expression is the quantity x plus 2 times the quantity x plus 1. This is called the factored form. A quadratic expression in factored form is written as the product of a constant times two linear factors. An expression in factored form can be rewritten in standard form by expanding it, which means multiplying out the factors. Remember that we used a diagram to apply the distributive property to two linear expressions. We can do the same to expand an expression whether the linear terms have sums or differences or a combination of two. For example, the quantity x minus 4 times the quantity x minus 1. Here is a diagram representing the product. Each term of one factor is multiplied by every term in the other factor. The quadratic expression x squared minus 5x plus 4 is in standard form, and the quadratic expression, the quantity x minus 4 times the quantity x minus 1, is in factored form. In this way, we have rewritten the quadratic expression from its factored form of the quantity x minus 4 times the quantity x minus 1 into an equivalent expression in standard form of x squared minus 5x plus 4. Thank you for watching video 3 of 6 for this unit on Introduction to Quadratic Functions.